Welcome to The Explainer. I am so incredibly excited you're here. Today, we're going to unlock a biological mystery that every single one of us has experienced, yet very few actually understand. We are going to turn our screen into an interactive whiteboard to decode the hidden, invisible biology happening inside your body during and right after intense exercise. Okay, let's dive into this.
I want you to picture this. You've just run as fast as you possibly can to catch a bus. You make it, you sit down, but for the next 3 minutes, you are absolutely gasping for air. Your chest is just heaving. But why? You're sitting perfectly still. Why does your body act like it's still running? Well, this isn't just your lungs being slow to catch up. There's a very specific, highly calculated biological mechanism at play here. It's a concept called oxygen debt. And honestly, understanding it completely changes how you look at the human body.
To help you totally master this topic for your O-level biology exams, here is our game plan. We'll cover 1. Why we keep gasping. 2. The types of respiration. 3. Oxygen debt explained. 4. Repaying that debt. And 5. Some crucial exam tips and pitfalls.
All right, part 1. Why we keep gasping.
To figure out the physical act of gasping, we actually have to zoom all the way down to the cellular level. And that brings us to our absolute foundation, respiration. Simply put, this is the biological process of how our bodies release energy from food, primarily glucose. Think of glucose as a locked safe, and respiration is the combination that pops it open to release the cash, the energy that your body desperately needs to function. Without this process, your muscles simply cannot contract.
Moving right along to part 2, the 2 types of respiration.
Now, what's really interesting here is that your body actually has 2 completely different combinations to open that safe. Looking on the left, we have aerobic respiration. This is where the glucose molecule perfectly combines with oxygen. This is the ideal scenario, producing a massive yield of energy and just leaving behind harmless carbon dioxide and water. But if you look at anaerobic respiration on the right, there is 0 oxygen. When glucose is broken down without oxygen, the energy yield drops significantly, and we get a completely new, kind of problematic byproduct, lactic acid.
So you might be wondering, why would our bodies ever use that second, less efficient method? Well, when you sprint, the energy demand in your muscles skyrockets straight up. But the oxygen your lungs can actually supply, it just can't scale up fast enough to match it. Your muscles' energy demand literally outpaces your oxygen supply, forcing your body to shift gears into anaerobic respiration just to keep your legs moving.
Zooming in on the muscle tissue itself, we can clearly see the micro-level consequence of this. Because you're operating without enough oxygen, that toxic lactic acid begins to rapidly accumulate and burn. This buildup is exactly what causes that heavy muscle fatigue and the sharp cramping you feel during a massive physical exertion. Your body is surviving, sure, but it's making a chemical mess to do it.
Which brings us to part 3, understanding oxygen debt. Your body has essentially taken out a chemical loan. Oxygen debt is the extra oxygen required after exercise to break down all that accumulated lactic acid. Your internal biological accounting scale is suddenly way out of balance. You borrowed energy without using oxygen during the sprint, so to clear out that toxic acid just sitting there in your muscles, you have to pay back the exact amount of oxygen you skipped over. Let's look at part 4, repaying the oxygen debt. So how exactly does the body settle this ledger? Well, as you can see mapped out here, it happens in a real-time sequence. Step 1, the sprint stops, and your physical movement ceases. But in step 2, your fast, heavy breathing forcefully continues. In step 3, that panting draws massive flows of extra oxygen straight into your bloodstream. And finally, step 4, that extra oxygen is delivered directly to the muscles to break down the lactic acid. You are gasping because you are literally inhaling your debt repayment. Crazy, right?
That extra oxygen basically acts as a biological cleaner. It chemically reacts with the lactic acid, either converting it back into useful glucose, which is great for restoring your energy reserves, or fully oxidizing it into harmless carbon dioxide and water, which you then just exhale or sweat out. Once the lactic acid is totally gone, the debt is paid, and your breathing can finally return to normal.
All right, let's wrap things up with part 5, exam tips and pitfalls. Let's dive into this.
We need to translate these mechanics into perfect marks on your paper by avoiding some really common traps. A massive mistake students make is vaguely stating that anaerobic respiration uses less oxygen. No way! The biological reality is that it occurs entirely without oxygen. 0. None. Another trap is ignoring the post-exercise timeline. Examiners will try to trick you into saying breathing normalizes instantly when exercise stops. You now know that is false. Breathing specifically stays elevated to repay that oxygen debt.
So, let's look at a classic high-stakes exam question you are almost guaranteed to see. Why does breathing remain fast after exercise? It seems simple, but to get full marks, you can't just save because you're tired. You have to show the examiner you truly understand the microbiological flow.
Here is your perfect answer rubric. If you get this question, your answer absolutely must explicitly hit these 3 points in sequence. First, state that fast breathing supplies the extra oxygen. Second, state that this oxygen is needed to break down the accumulated lactic acid. You can optionally note that it converts it back to glucose or oxidizes it. And third, state that this process restores the body's energy reserves. Hit those 3 bullet points and you secure full marks every single time.
Let's do a rapid-fire recap just to cement this into your memory. 1. Anaerobic respiration means absolutely no oxygen, which produces toxic lactic acid. 2. That lactic acid buildup creates a biological oxygen debt. 3. The fast, heavy breathing you experience post-exercise is your body's mechanical way of inhaling extra oxygen to repay that chemical debt and clear the acid.
So the very next time you sprint for a bus and collapse into your seat feeling like your lungs might explode, pay close attention to your chest heaving. You aren't just out of breath. You are a biological accountant, frantically balancing an internal ledger. How much chemical debt is your body secretly accumulating in those few seconds? Keep asking questions about the invisible world inside of us, and I will see you in the next explainer.